So the theories behind the lifting forces of a wind is because of the airfoil design, Coanda effect, and Bernoulli's principle. Now, the design of the airfoil, which is shaped like this, uh, it has a flat bottom and a curved top. And sometimes when it is placed on an airplane, it has an angle of attack. The first theory is Bernoulli's principle. It states that whenever the air, any fluid that has a high velocity, it has a low pressure, while a low velocity air or fluid has a higher pressure. An example is a tube with a flowing fluid with a restriction in the middle part. As we can see, the steady flowing fluid or slow moving air. Let's say it's an air, slow moving. Then suddenly, when it reaches the middle part wherein it restricts the air from flowing, the air speeds up because the area of the cross-sectional area of the tube is going to be smaller, therefore creating a faster velocity of air, therefore making it a low pressure. Then as soon as the tube expands again, the velocity drops and the pressure increases. Now, in relation to the airfoil, as we can see, the top portion has a higher distance compared to the bottom portion. The bottom portion has a flat bottom and the upper part is curved, which is typically longer. Now, as we can see, this is the wind direction. As wind passes through the airfoil, it splits into two. The other one goes up and the other one goes down. The one that goes down travels the shortest distance and a simpler path as a straight line going downwards, while the top part, as the air splits, the air will follow the longer distance, then meet at the end, at the trailing edge. As we can see, in order to keep up with the speed of the air in the lower part, the air above must speed up in order to keep up with the speed in the bottom. Therefore, the air speed on the top portion will become higher compared to the lower part. Therefore, the upper part will have low pressure, and the lower part will have a higher pressure. Therefore, producing lift. Another reason why fluids airfoil design makes or produces lift is because of the Coanda effect. The Coanda effect is a phenomena wherein jet stream of fluid tends to follow a convex surface. It is because if jet stream commonly traveling at a fast speed, as we can see, this is a stream of fluid. It is fast moving, therefore low pressure. The air around it, this one, the air around the jet stream are steady, therefore the pressure is high. As soon as the rushing air passes through the steady air around it, the steady air tends to push or go with the flow of the fast moving air. As you can see, this is the place where the Coanda effect happens. The air on this side is steady and a high pressure, while on this part it has a low pressure because there are no surrounding air in this part, just a solid or rigid concave. Therefore, when a fast moving air passes through this concave, a convex shape, the steady air around it tends to push the stream inwards, going through the going or following the shape of the convex. There is no air to pull around here, therefore low pressure then high pressure here. Then the steady air pushes the stream inwards. Now, in connection to the airfoil, as we can see, this is the part where I can say that it is convex, the upper part, the curved part. As we can see, as the air or the wind wind passes through the airfoil, it splits to two. The other one goes down and the other one goes up. Now as we can see, the air tends to follow the shape of the airfoil. It is because of the steady air around it. Then this is a solid, right? There is no air around it to pull, therefore making the stream of air follow the shape. And as soon as the wind follow the shape, the wind direction changes. So from a parallel direction, it is going to be changed by the airfoil going this way. Now, if you can remember the Newton's third law of motion, in every action there's an equal and opposite reaction. The wind being pushed down will create lift, opposite reaction. As the wind goes down, the airfoil or the wing lifts or produces lifts. That's all. Thank you.